I'm good. Right. Okay. So good morning. Good afternoon. Right. 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 Yeah. So we start at 1:45. Right. So another 3 minutes there. So I'm just waiting for the kids who are joining online to actually getting. Hmm. Are you? Okay. Can hear. Right. Those who are joining online, you can type. Um, can you hear? Everything all right? Anything? Right. Okay. So 2 minutes earlier. 2 minutes early. But you relax, you see, spread yourself a little bit. But don't do that. Spread a little better. Right. A little dark. Maybe because of that. Maybe because of that. We will switch on that light as well, right? Otherwise, half of you will be sleeping and other half will be gone after some time. Let's see. Then you can't see this, but it's okay. There's nothing much to see. Right. Okay, so let us begin. Right, still they're also on time. Our friends are on time. 45. Come, sit down. There's one more minute to go. One other minute. Right? Yes. All okay? Right. Please settle down. And I am Vajira Senaviratna. Right? Come. Right? Vajira Senaviratna. Right? And I teach chemistry. Right? So chemistry. So this is, and I'm little passionate about chemistry. That's the only thing I can share with you. That's the only thing I can share at the moment, right? Vajira, chemistry, right? That's all, right? Uh, so since this is the first day, now O-levels, just after O-levels, I'm sure you are excited to start your A-level career, and then you are looking forward to do some work, right? So maybe you have selected biosciences, maybe you have selected physical sciences. If you want to go to a kind of a proper faculty, you need to do chemistry. So that is why you are here. Then today is our first day. I have given you certain materials. Can you look at both the materials that I have given you? First one, there's a booklet with Marie Curie in it. Marie Curie in it. There's a small booklet that I have given you. So that booklet provides you, right? You can turn. Don't look at Marie Curie and wait. My God, she is so stunning. Kila balangin, di ba? Right? Look at, yeah, yeah. One of the fascinating chemists and physicists in the world, Marie Curie. But inside this, you will find the very brief description of the syllabus that we need to cover. We'll talk about that. And then subsequent pages, the remaining pages, you will find remaining pages, you will find the detailed version of the first unit. Detailed version of the first unit. Turn the pages just to see details of the first unit. Nothing much. Details of the first unit. And then we will see how we are going to cover them gradually. So just keep it with you, right? Keep it with you. I will provide all the other necessary details with time, right? Okay. So at the moment, until the schools begin, this is how the schedule, I have given the schedule as well. Okay, schedule laga तीनों, right? If you go to some of those pages, yeah, in that booklet itself, inside that booklet, if you turn to first page, second page, you are given the schedule. You're given the schedule. Normally Fridays, right? Friday. All Fridays, starting from today, we will now starting from next week, I'll start at 1:30. Right? I started today 1:45 in order for you to find the places, those kinds of things, because this is the first day for you. So many of you, it's a new experience. I just wanted you to come early to the place and then find the place and get accommodated. 1:30 now, starting from next week, I start at 1:30 and it will go till 4:30 p.m. Right? 4:30 p.m. 3 hours. I'll give you a small break in the middle because you are still getting used to this bigger, like a longer classes. But so 1:30 to 4:30. Right? Starting from next week. So don't worry about that now. We will worry about it tomorrow. Right? Exactly 1:30. All that. So that we will do it next time. Come sit down. Everything falling apart. Right? Yes. Okay. Right, Hari. Right. Okay. Yes. Right. Right. So that's it. And then there's a reference book that I have given you also. If you ever want to invest on a good book, I recommend that book. That is Chemistry by Raymond Chang. Right? Chemistry by Raymond Chang. You have given references. Further reading. මේ චේතන අනේ පුතා මට මේ කැනුගෙත් අර මම ඊළඟ එන්නකෝ මේ ටියුටෝරියල් එක දීපු අය මේක දීපු අය මේ කටියට දීපු එක දෙන්නකෝ ගෙනල්ලා come පුතා come quickly and very quickly right yeah I forgot to get that also I will take the blue tutorial then no more talking පුතා talking right so Friday for 1:30 to 4:30 and then our book is what is the book? It's in Chemistry by Raymond Chang. I have a soft copy. I will send that to you, like when you are okay, when we settle down, I will send that to you. Right? Otherwise, it will be too much of material, right? So this is your tutorial. I told you. Now, so in the first page, it gives you the list of topics, right? In the second page, I have given you how, the schedule is class schedule. And then there's references, and I have given my personal telephone number also, 077 840 259. I'll write it here. 077 840 259. That is it. So this is a class where, I want you to kind of really become interested in chemistry. I want you to become passionate in chemistry and do work. So I'm I'm not going to, since this is the first day, I'm not going to say what are the things that we are going to do. But then don't worry. We will give you the complete theory, up to date, every little detail. I will never give you any videos and ask you to watch. That is one of the things I can promise. Right? If you come here personally, I will do this personally with you. Entire thing that will be covered. Right? And then we will have exams, very regularly we have exams. And then I am the one who is marking the papers. And I give you your personal marks. And those marks I don't publish anywhere, so that it's very personal to you. If you get a 90 mark, still others don't know. If you get 20 marks also, others don't know, right? So it's a good thing, right? And but then if you get more than 80 marks, I give you a small threshold. I give them a gold medal. End of the year, if they do really well, out of that, if they become top, I give them a cash prize. I will again, if they become top, I will refund the entire class fees to them. Then to their parents. Refund the class fees to their parents. Say my and sit down. Don't go to the back. Right? You're comfortable? Right. So I'm telling you, I'm not going to tell you much thing about these things. So all in all, I think we should be able to do a kind of a good job. I think try it out. Yeah, whether you understand what I am going to say. But then if you feel like that you don't understand it, you have to try out another master until you find something that is worthwhile for you to listen. The monkey right? Did you understand that? So you try out. It is all the option is yours. Right? Like the remaining parts I have given the first lesson that we are going to cover and its details. Right? Right? But don't look at it too much. When you look at it like so deep, you will feel little afraid of it. Huh? So that is that you this thing. Then there's a there's a set of diagrams that I have given you. These ones are really useful when you are pursuing the remaining parts of the studies. Keep it with you. Huh? I will tell you when to use it. That's the second thing. Third thing is the tutorial number one. Tutorial number one. There's a purple colored tutorial that I have given you today. So what we're going to do is, don't look at that. Don't look at the tutorial. It's tutorial number one, Introduction to Chemistry. So today, after listening what I have to say, I want you to find the answers to this. And we will discuss those answers before you go. If you can write and get full marks, that means you have understood me. Right? That doesn't mean that if you can't write the answers, that doesn't mean that you are bad. That means I have not done a proper job. Right? That's the only thing, right? But I will try my best to do a good job. Right? So that is that. And then you have this periodic table. This is one of the man's anthropological marvel. I tell this. This is one of the anthropological marvel. What is anthropological? Anthropological means man-made. Man-made marvel is this. Like you starting from hydrogen, you go to different elements that's been ever discovered. All of them are organized in a proper order and has given a magnificent table onto you. So many people have given their life towards it in constructing this. Their ultimate life devotion was to construct this table, identify a single element, discover a single element. All that man-made thing is concentrated in one table, very useful table, and it gives you the period. That's called the periodic table. So I have given you a kind of very nice laminated periodic table for you to keep. On the other side, this should be the motto that you should always have. You should never give up, whatever the challenges that you will ever face. With keeping that in mind, I will start my lesson straight away. So sometimes you might have to write certain things. The thing that I don't want you to do is to sleep. No sleeping, but you can listen. Right? There's nothing much. I will give you a very quick summary later on. Right? Did you understand that? Right. Okay. So I call this the chemical world. The chemical world. So I want you to see this. Now, in order to facilitate seeing this, I'm going to switch off that light. Okay. Right. If you're tired, tell me, right? If you're tired, tell me. So let us see what's been told here, right? I hope everybody can understand. You can ask questions if you want, but then let us see whether we can try to understand what it is. So I start this lesson called Chemical World, right? Chemical World. Now, if you know the entire world that we live today, right? Some people ask whether this is a God's creation. That's a common question that's been always asked. Is that the God who created the world, who has created the universe? Right? And some scientists argue, no, it's not that. There is this unity, one singular big black box or black hole or something like that. And there was a very big bang that took place. They say that no, you all are Generation Z, you know everything, right? So they said Big Bang. They say Big Bang theory. I'm not going to argue. I'm nobody. I'm like a very humble person. I'm nobody to say whether it's the God's creation, whether it's the Big Bang theory, because I don't know anything. Next to nothing. I know next to nothing. So I can't argue whether it's the Big Bang theory or whether it's the God's creation. But the only thing what we can always say is one simple thing. Whenever you go to the edge of the universe, they always see this blue marble that they talk about, isn't it? What a magnificent word that we think, right? The blue marble. What about the pain at the what's up? Huh? Light to go me මෙතන අපිට lights off කරන්න නේද? ඔම කරන කලවර මේ දන්නේ නැහැ. That's the thing. So they say that this is a blue marble. You know, there's this right tiny little blue like planet that you see from the edge of the universe. Right? I have never been to the edge of the universe, so I don't know. We are relying on pictures, right? So they say that it's really magnificent thing. But if you look at all the evolution that has taken place, nowadays, if you look at the evolution of mankind, you see, look at some of those animals that is there. Look at the animals that is there. Now, I have some questions to ask later on. Look at these animals. One of the biggest problems for all these animals is this extreme competition for food, isn't it? So there are three things that should happen. First one is you should get food. There should be some food. And you should keep that food. And you should not become food of somebody else's. You understand that? So you have to survive. That's one of the biggest things that is important in any living being. That is one of the biggest things that is important. Survival. But if you look at all these animals, look at that. Black panther, snow leopard, I don't know. I'm just saying various names. Huh? Don't think about this. Some kind of a cheetah. What is the rhinoceros? Yes. Like, they all have these utmost advantages. What are those advantages? They are, right, many animals, they're very big animals, like, big made animals. They're very tough. They're very fast animals. They can run fast. They're very strong compared to what? Compared to human beings. And they have sharp teeth. All these animals, look at them, they have very sharp teeth. And they have tougher skin and had a better vision. And they have a better sense of smell. So, meaning all of these animals, they have this edge over the survival. They can survive themselves better than what? Better than the mankind. Men doesn't have that. When I say men, women included, everything, right? Men, women, human beings didn't have that. All the other animals, they had this, they're very tough. They can survive for a long time. The only difference is the man had a bigger brain. They can think about it. They can look at something. They can become curious about that. They can also try to understand this, come up with various types of solutions to solve some kind of a problem they always face. That is what you have always done. The mankind, they can do that. Even though they didn't have very sharp teeth, better sense of smell, better vision, they were able to come up with different types of tools that they can find in nature. They can find in nature various types of things. They can take this material, they can sharpen them, and they can build up various types of tools. That is how the Stone Age began. And that is their own teeth. They can use different types of stones, and they were able to make various types of arms so that they can kill animals, right? They can survive. So that is one of the things that people have always encountered in their evolution. So people, whenever they walk around near volcanoes, look at these things in your Google search, see whether they are right. Whenever they walk around near volcanoes, they find something called obsidian. Yes, obsidian, right? So remember, I want you to hear that obsidian. Very glassy-like structures, glassy-like rock material. You can take these rock material, break it, hammer it, and you can sharpen them into tools. How sharp it is, even surgeons believe they are very sharper than the best surgical blades that we have ever have discovered so far. That's sharp. So molten rock made out of silica, you can use that natural glass called obsidian, and you can turn this into very sharp tools, right? So very good. That's one of the important things is making tools themselves. They didn't have all kinds of all these problems were there. They didn't have the sharpest uh, vision, not the sharpest smell, but they had a good brain where you can take something that is in their surrounding and they can build up their own sharp tools. So that is where the stone technology came up. Now this is good. This time, now, mankind is better. They can, when they are hungry, they can kill animals. You don't have to come closer to them. There are stones, sharp tools you can throw at people, and you can, not people, don't throw at people, but animals, and then you can kill them, and you can bring them, and everybody feasts around it. It's a good thing, right? So extreme competition for food, and you are not becoming food, you have something to eat, right? Now people are happy. Then the problem is, then the next discovery of the mankind was creating fire. Of course, you have learned this for your O levels. Creating fire. Now you understand, knowing the art to make fire, knowing the art to make fire is great. Why? Because if you know how to make a fire, you can light it up. It will scare away the predators. It will give the warmth. And you can put food and you can cook them. So it is better. It is easy to digest. It tastes little better. You can keep it little longer. Did you understand that? So creating fire is a very important thing for the survival, right? Back in the days, how do you create fire? You have to wait until lightning strike on some rubber. It catches fire and you need to take that fire and you can have to keep on lighting that fire for a long period of time. That is how you keep the fire. But later on, people realize that if you want to make a fire, you can do it this way. I told you it gives you the warmth. What else? It softens up the food. What else? It makes the food safer to digest and it scares away the predators. I told you that, right? But then if you want to light up fire, this is how you do it. You might have done this as well. Like as small kids, like, you apply a little bit of a friction onto this, put some kind of a fluff, dry material, allow it to burn and magnify the fire there. So that is how they do this. Even nowadays, various remote islands, people in remote islands, they do the same thing to create fire. But they now know how to create fire. They have that edge of survival. That's a good thing, right? Okay, so this is really good. Now look at how the mankind go here and there, right? How do they behave? Like, if they want to kill animals, they can kill animals. They go hunting. They have sharp tools. Kill animal. They bring the food. right? And they don't have to eat it on one day. You can, like, dry it. You can change the taste of it by heating it, barbecue it, and you can eat. People are happy. Now you don't have to go hunting every day. Maybe twice a week or something like that. You have to go hunting. Little happier. But then they thought, okay, now you get like a lot of meat and you want to store it. You have to store it so that you don't have to go hunting every twice a week, only maybe once a week, right? They realize that whenever you place clay in fire, what will happen is there's changes that would take place. What are the changes that would take place? You know what is clay? Muddy. You take clay and you fire clay. What will happen? What will happen to the clay? It will solidify. It doesn't shape. It doesn't change the shape. Did you understand that? It doesn't change the shape. So what they did was they used that clay and they fire clay and they made various types of pots. Early historians say that they have made different types of pots. What is the advantage of a pot? Are you sleeping? No. Right? Yeah. I'm going to put you in a clay pot. Right? Yes. What happens when you fire like when you have clay pots? Now this is better. Now these are acting like storage devices. You can go hunting, bring food, prepare them using fire. You eat it, but if there's too much of food, you can keep it inside there, inside the pot. Yes, inside the pot. Right. When you that helps you to store things. But when you store things, there's a little bit of a problem. When you keep on store things, what will happen? Your ants crawl in, small insects crawl in, bacteria try to grow, fungi try to grow, it gets spoiled. Have you ever experienced that kind of a thing? Of course, you haven't eaten, but I'm sure you have seen spoiled food. Of course. Ants walking around, a bigger problem. Now you can't, even though we try to store it, you can't store it for a long time. So do you want to try and store these things? How do they store this? They want to preserve food. How do you preserve food? They wanted to stop these ants coming in, like all these, but fungi growth. They want to stop the fungi growth. So in order to do that, they use the material. Now you know the art of creating fire. You can cook, and they also dry the material. And once you dry them, you can keep it for a long period of time. That is also better. Right? But at the same time, they understood that, you can get a sugary material called, from grapes, you can get a sugary drink, grape drinks. But if you take this grape sugary material and leave it for some time in a pot like that, it turns into alcohol. But people have been drinking alcohol for a long time. Right? They do all kinds of stupid things, but they drink alcohol, right? But if you keep alcohol even for a long time, what will happen is they turn into something called what? This is like wine from grapes. This is ethanol. It's called C2H5OH. Ethanol is C2H5OH. It's called an alcohol. Ethanol. But this ethanol, if you keep it for a long time, it will react with the atmospheric oxygen here, right? It reacts with atmospheric oxygen and it forms another compound called acetic acid. Have you heard acetic acid? CH3COOH. The reaction is not balanced, right? CH3COOH. What is acetic acid? Have you heard? What is that? The common name, you have it in home also. Vinegar, yes. So from wine, right? When it becomes stale, when it ferments a little bit more, it gives you vinegar, wine, right? Vinegar. So that is how the word comes, vinegar, right? So that is what's there. And do you realize by taking acetic acid, you can keep the food even further. That acts as a good preservative. So it removes a water molecule and it gives you this new material called vinegar. Even nowadays, people use vinegar, isn't it? They pickle eggs and all kinds of things they can pickle, right? Thing that is not being pickled is human flesh, I think. Other than that, everything is pickled these days, right? So pickled, because it will inhibit the growth of bacteria. So this will stop growing bacteria and you can keep it for a long period of time. I'm sure every one of you have eaten some pickle one day, right? Right? So all it's there, right? So material is there. So vinegar, you can see now new molecules coming to play. People use different types of chemicals for their development, right? To solve problems in the day-to-day basis. Whatever the problems that you have in the day-to-day basis, they try to solve this using different types of chemicals. You can see that. Right, and after that, they use different types of spices. You have used spices, of course, like coriander. What are the other spices you know? Cardamom, clove, cinnamon. Obviously, Sri Lanka is very famous for cinnamon, like you said. So, like this, you can use different spices, not only to enhance the flavor, but also as a preservative. So you can keep food for a long period of time. Hari. Now things are good. Well, if I give you a small break here, things are good. Think about this. Now you can go hunting. There are sharper tools. You know the art of creating fire. They scare away the predators. It increases your survival rate. And you can now have clay pots where you can store things. They are not destroyed by pests because you have vinegar and various types of spices, right? This is good. Like those kinds of civilization took place near rivers. And people are generally happy. This is good. But then, now let us say you have a city like this, let us say some kind of a village where there is a river. There is this civilization somewhere here. There's some kind of a civilization somewhere there. You have to always understand that there's always burning something here. So there's smoke going up like that. So they're basically very happy with each other. But only thing is, the man is like, even though you have a great mind, everything is great, they are always blessed with evil hearts as well. Can't be even though fairy tales say happily live ever after, there's no happiness ever after. There's always a problem, right? So mankind, they are well sustained, but there's a problem because all of these people sometimes want to conquer others. They want to get all of their wealth and try to, because people are greedy as well. So one day, what happened was, these people, they thought, let us go and attack them. So wars now then trying to attack. Right. So these people realize that they are undergoing attack. And then what do they do? They want to cover their place. How do they cover their place? You don't have GPS like nowadays. How do they cover their place? They locate their place by the smoke that is going up. That is how you locate. Yeah, there is the smoke and there might be a civilization. Let us go and attack them. So what do they do? If you want to conceal this place, how do you conceal it? By covering the Smoke. So what do? How do you cover the smoke? You put some rubber into it or put some water into it. Did you understand that? So one day when these people were attacked, they put some kind of rubber that is surrounding it, and then they concealed the entire fire. They ran away. These people maybe have come there, take all the materials, they go back to their own place. Clear? Right. So when they went back to their own place, right? So what will happen? After some time, they gradually come back. Those who ran away, they come back. And they realize there's something unusual going on here. Something unusual. Like, I'll show you some images. This happened in 1,000 years ago in Andes, where they had some dirt material that was there. You can see this is like, slightly blue in color. Slightly blue in color. They put this rubber into this. And when they come back, it has changed into something like that. Right? Something like that. So they were fascinated with this, like, metallic kind of material. There's some kind of luster into it, metallic luster, a shininess into it. And they were worried, what is that? And when they were worried, what is that? They took this and they try to, like, hit it on my mallet and try to see whether there are any shapes that can take place. And suddenly realized that this is like a metal. They didn't know that at that time. What has happened was, this material was this copper oxide, CuO, copper salt containing copper salt. This blue color comes from copper. Copper oxide, rich mineral. And if you put this into fire, there's always carbon in it. Fire contains carbon and you have heat. When you heat it, what will happen is this carbon combines with oxygen. It gives you carbon monoxide or carbon dioxide, and you get copper. Balance this oxygen. This is two oxygen. 2 copper to balance. You have 2 here. Carbon dioxide is a gas. It evolves away, and copper extracted. So this is actually copper. It's a metal. Copper wires are used in our homes as well to conduct electricity. But this is the first time they realized that there's some material. This material is really good. It's not like obsidian. You don't have to hammer it again and again and again into to make a sharper tool, but you can make this into sharp tools very easily. Just by simple hammering, you can turn this into a sharp tool. There you get the Bronze Age. So from Stone Age, you gradually go into the Bronze Age, where you use copper materials, different types of metals being used. And they have used as the survival tools instead of the Stone Age, right? So you can see, like, various types of chemicals beginning to appear as you progress through their survival, right? Okay. So that's what happened. So starting from very early stage, they just want to survive, right? So Stone Age and then Bronze Age. Then what they did was they wanted to understand more and more materials. They were curious about nature, nothing much. Curious about nature. They try to understand more materials. More they try to understand, more discoveries they were made. Right? Now these are called alchemists. After, like, about, let us say, 400, 500 years before, right? These are the prehistoric chemists, alchemists. Now, alchemists, they had only 2 things in their mind. What are the 2 things? They wanted to make gold. First thing is gold. They want to make gold. Everything they wanted to make gold, turn into gold. Why gold? Because it is precious. It doesn't react. It doesn't tarnish its color. nothing is going to happen to them. So they wanted to make gold. That is one of the first things they wanted to do. The other one is now they realize that everybody is dying. These people wanted to come up with a method that everyone is immortal. No one is going to die. So you take a drink of this concussion, drink it, and no one is going to die. Elixir of life, it was called. So they were experimenting for that. They were not doing chemistry. They were experimenting for a prolonged life, right? We still haven't found that, I think. I don't think we have still found it. But you can see there are all kinds of clay pots that are there. That you can create fire, you can like enhance the fire. Like, there are students working for them. There's a kind of a small kind of classroom kind of thing, laboratory kind of thing, study that, right? And then working it out. Can you see? Did you see that? Very good. Very good, Hari, right. Okay, so they were doing that. You think, right? Okay, so there's a nice story. Somebody called Brand. He is alchemist as well, this guy, Brand. He thought, okay, I want to find some gold out of the natural materials that is there. And he realized that when people urinate early in the morning, he realized that there's a kind of a yellow color into urine. So yellow color into urine. And he realized that, okay, he thought, maybe there's some amount of gold in it. That yellow color is due to the gold particles, tiny gold particles in urine, he thought. So he thought, okay, I am the first to isolate this, right? If you are the first to isolate this, you are in great big discoveries. He thought, I will get some urine. He got 1,500 gallons of urine. 1,500 gallons of urine, right? Brought home all that 1,500 gallons. And what he did was, he evaporated this. What do you mean by evaporation? What do you mean by evaporation? Evaporation means you heat it and allow it to go dry. You allow vapor, water vapor to go into the atmosphere and gradually concentrate. So when he was gradually concentrating this, suddenly he's now, what is he expecting? He's expecting for a block of gold. My precious, right? So he was expecting that, but he didn't find gold. Suddenly he saw a kind of a white smoke, a bright white light. So this is that, right here. So this is this guy. You can see a bright white light. Now, bright white light, even though we are now very familiar with white light, at that time there was no white light. At that time, only light was the candle light that was there. So he was not accustomed to white light. He was only seeing the candle light. And suddenly in his laboratory, there's this bright white light. At this era, he thought, bright white light is only imagined with imagined with God. Angels, whenever they thought angels comes into the laboratory, it gives you a bright white light. Okay? Did you understand that? But he is seeing now bright white light in his own laboratory. He thought the angel has come or the God has come to visit his laboratory. He has kneeled down. That is why he's kneeling down there. Right, okay, all that. Right? But when he realized, he realized this. He realized, at that time he knew, but he has discovered phosphorus at that time. That is how he has discovered phosphorus. So he discovered phosphorus. Complete a chance of discovery, right? He was not going to discover phosphorus, but he discovered phosphorus at that time. So likewise, you can see copper, oxygen, carbon, alcohol, acetic acid. Now you know phosphorus. Phosphorus is the bearer of light. The phosphorus stands for the bearer of light. When you burn phosphorus, it gives you phosphorus pentoxide, right? Phosphorus pentoxide. And this is, let us say here it is 2, this is 4, 2 times 5, 10, 5 times 2, 10. So it gives you that kind of a reaction. Don't worry about those reactions. Huh? Don't worry, right? So it gives you this. This phosphorus pentoxide gives you a kind of massive bright white light. And he discovered that. So all in all, now science became some kind of a mainstream story, right? At the very beginning, science was used to safeguard human beings' survival. But later on, science became a mainstream. It will help you to do a lot of new things, right? So these people like John Dalton, famous Avogadro, Niels Bohr, Rutherford, J.J. Thomson, and you were looking, I was staring at that picture, Marie Curie, they discovered a lot of things. They have discovered a lot of new things for the chemistry and physics, right? So that is that, right? So that they have discovered so many things, new things, but they were just trying to survive and try to understand how things are. So that is like medieval chemistry. Now, modern day chemistry, the chemistry that we try to study, that is how science became actually a chemistry. Chemistry became a science at the end. Nowadays, when you say chemistry, we are not discovering, we are not trying to discover how the philosopher's stone comes in. What is philosopher's stone? Philosopher's stone, what is that? Right? Something that can turn into gold. Philosopher's stone, or Harry Potter and Philosopher's Stone, that one, right? So, and then the elixir of life become immortal forever. So all these things, they actually came, like, those things that they try to investigate, new things to be discovered. Now, modern day chemistry is, we are not discovering, we are not trying to discover any of those things. Not the Philosopher's Stone, not the elixir of life. But the modern day chemistry is divided into many classes. We have something called general chemistry. General chemistry, right? And then we have something called inorganic chemistry. Inorganic. Then we have something called organic chemistry. We will look at them. Then we have physical chemistry, right? And other than these four, we have something called biochemistry, right? Then we have industrial chemistry, and we have environmental chemistry. So these are divided into these kind of classes of chemistry. In general chemistry, we are looking at the general basic background. So even if you haven't understood certain things in your O-levels, this is the time to understand it now again. Inorganic chemistry, except carbon, all other chemistry in the periodic table is inorganic chemistry. Organic chemistry, carbon-based materials, we study under organic chemistry. Physical chemistry, mathematics related to all of these things. Biochemistry, chemistry related to biological aspects. Industrial chemistry, all these chemistry that we learn, you put into a useful thing under industry. So that is where you will use industrial chemistry. But whenever you have industries, what happens? It has an impact on the environment. And we try to minimize that environmental damage. That is called the environmental chemistry. Did you understand that? Right. Okay. So modern day chemistry has so many sub-disciplines that are there. And we will gradually try to learn them, right? Learn them. as well. Now, if you look at it, how about that? Right? Then I'll give you the questions. Where are we heading? Then if you drink a morning cup of coffee, scientists know all the molecules that are there, how these molecules go into the body, how they interact with the cells, how you get that alertness. Everything is known. People know them. So we have, that's why we try to understand the chemistry, try to understand the study of chemistry to make new materials, always to make new materials. Now, look at the materials that you have. No, all of these are chemistry-based materials. Now, see, check whether you have used any of these things in your lifetime. Various types of medications, of course, that is thanks to chemistry. Various types of molecules being synthesized. Chemists are the ones that will synthesize. Doctors prescribe it, but chemists are the ones that will make the actual drug and make sure that drug is effective and it is not poisonous to the body. Medical imaging agents, if they want to look at the entire picture of the heart, they maybe pass some kind of a dye to it and then get a kind of a super contrast image based on these kinds of materials. Various types of herbicides to kill various types of pathogenic materials, pesticides to kill insects in agriculture, fungicides where various types of fungi can grow. You want to get rid of them. Chemistry is the one that will help you. Plant growth hormones, fertilizers. You remember about 2 or 3 years back when people banned fertilizer to the country. The entire country went through a huge chaos. You remember that? So fertilizers are very important. Urea is one of the most important material. Antiseptics. Antiseptic means whenever you have some kind of a cut or a wound, what you do? You put some kind of antiseptic on it. Give me some examples for antiseptic. What are the things that you have used? Antiseptic, hydrogen peroxide have you used? Maybe there will be a small amount of hydrogen peroxide. What else? Surgical spirit. Surgical spirit you might have used. What else? Have you used Dettol? Dettol is antiseptic agent. What else? Something called betadine have you used? Betadine is also an antiseptic agent. So these are all various types of chemicals that are there. Like disinfectant also, it's like that. You just want to kill various types of pathogenic materials, right? Look at the manufacturing products that you have, fibers and clothings, right? There are your clothes, all these clothes, synthetic clothes are made out of various types of chemical-based materials that are there, right? And then plastics. Of course, every one of us have various types of plastics. They are all thanks to different types of polymers that we use. Coatings, right? Maybe look at your glasses that you use, you might have a coating on it. Maybe your phone, you might have a coating on it. These coatings are made thanks to the new research that they do in chemistry. Your paper, there's a paper-based industries, packagings, medical implants, wound dressings, all these are chemistry-based materials. Chemistry is an important material. You think about food, sugars, right? That's a organic molecule, fats and oils that use, vitamins, flavorings, antioxidants, colorants. Well, she is sleeping. You know what is a fuel? What is a fuel? Something to burn, right? So, various types of fuel can be taken from fossil fuels, like liquid petroleum, LP gas. Natural gas is methane, CH4. Methane, CH4, natural gas it is called, right? Coal, peat, methanol, ethanol, diesel. Remember, you imagine, we think chemistry is not visible, but you have to understand the importance of chemistry whenever they say there will be no diesel tomorrow. Right? So everybody is queuing up and there's a big chaos in the country. You know that? Diesel, petrol, they are very important ones. They are all separated based on chemical aspects. And you do this in industries. You do this in industry. That's what you have, right? Okay. Now I want to do, now we talked about a lot of things, right? I showed you a few diagrams and all that. And at the very beginning, I told you, after this, I want you to write answers for these 10 questions. Balanda, there's this purple colored tutorial, right? If you, there's a purple colored tutorial, right? I want you to read that question. Don't write the bonus question, right? Don't try to write the bonus question last page. But the remaining questions, MCQ, can you write the answers? I'll give you a few minutes to work on that. I'll give you a few minutes to work on that. Question and try to answer this. Out the color in the part, there's no number ones here. No last people here, right? Only thing is we need to be genuinely curious about what we are going to do. It's all right. Just read that, come up with some answers. 10 questions are there. Find answers, will you? Find answers. Write your name. Right? Write answers. Check whether you have understood what I was saying. If you have understood that, I think we should be able to, gradually come up with an answer. Right. Okay. Right. Come up with an answer. May don't throw away the periodic table. Huh? You have is it clear? Check whether you can understand that very simple kind of a story here. Can manage. It's like a general knowledge as well, but at the same time, write down some answers from the options that is given. You can understand, right? Right? Can you manage? Everybody? Right, okay. Hurry. So if there are questions you can ask, and at the same time, if you these this lecture may I gave just for you to become familiar, right, with my speaking style, and then that's it. But this tells you how chemistry became a science. How did chemistry become a science? How did this chemistry become a science? You okay? Can manage? How about you? Yeah, okay. You all right? You okay? Can manage, right? Okay, right. So do that. Clear? Did you understand? Right, okay. Can manage, Buddha? Right? All right. Shape. Everybody okay? Right? Clear? Right. So this is what happens. And right? Clear? Everybody okay with this? Niyamai. Did you write the answers? Huh? Hmm? Which method was not traditionally used for food preservation? Freezing. Freezing is the one. Yeah, but then not traditionally it was.
But I don't think they're not.
Yeah, because like when they discovered fire, like they put materials into that, and that is the cooking.
That's like
It preserved for a yeah, but then it is not available for everywhere. And like for example, at the very early stages, the civilization took place near the equator. So at that time, the freezing was not there. So that was the answer I expected. Yeah. Right? You have some good answers. Okay? Yes. Good answers. Children, did you all finalize answers? Okay, I'll give you another how many minutes? Another, let us say 3 minutes. No, you don't need that much. Right? 3 minutes. Mate, don't sleep. මල්ලි කොට්ටයක් ගෙනත් දෙන්න මෙයාට මේ can manage. So you're able to do this. Finish. Answers. Shall we look at the answers? Are you ready to look at the answers or right? Okay, let us look at these answers then. Right? Right, Uda. Now I want you to now this is the most important thing. Now this is learning science. So learning science, whenever you are learning science, you have to always remember to ask questions. Without asking questions, you can't learn science. Even though I am saying it, right? Don't trust what I say. If you have a problem, you need to always ask questions. Right? Don't take it as a sir tarahawe. When you ask questions, that is better. I sometimes learn from my students as well. When they ask questions, I sometimes learn. That's a really important one. Okay, right. Shall we start? First question, now. First tutorial, first question. My God, this is a very important stage in your life. Right. What was one of the earliest technological advancements that helped the human to survive? What was that? Farming, writing, fire, metal tools, pottery. What is the answer? Fire is the answer. Learning to create fire, right? Before metal tools and all that, metal tools arise after discovery of the fire. Very early thing that was important to survive was understanding how to make fire. So answer number C, right? 10 marks for that. හරිද? Right. හොඳයි. Right? Out of 100, out of 100. හරිද? Second question, right. Second question. Second question. What natural material was used to make sharp tools near volcanoes? Obsidian, right? Very good. Second one is also C, obsidian. Now you remember that obsidian is a glassy-like structure, right? Glassy-like structure that you can sharpen into very sharp tools, right? Good. Third one. Which of the following was not an advantage that animals had early humans? Sharper teeth, faster speed, stronger muscles, ability to make fire, better sense of smell. Ability to make fire. So, third one, What is the answer? Third one is D. Ability to make fire. Correct? Right. Question number 4. Question number 4. What was the significance of fire in clay in the early human civilization? It made clay bowls more decorative. It allows storage of food and liquids. It improved the taste of food. It created stronger weapons. It increased the weight of objects. What is the answer? Huh? It allowed the storage of food and liquids. Of course, it improved the taste of food, but not the firing of clay, right? So this is, it improved the taste of food. Answer, see, B. B, it allows storage of food and liquids. Right? Agree there, everybody? Yes. Hari, go to the next page, will you? Which method was not traditionally used for food preservation? Freezing, yes. Well, because one of your friends asked me this question. I think it's a very good question. He said, okay, in places like Arctic, Antarctic, people have been freezing. But in the early part of the civilization didn't take place at that point. They took place in the places where you have a lot of water, right? Streams and rivers and all that. In these places, freezing was not an option, right? So, people have been doing drying, fermentation. Fermentation is using, vinegar kind of material, and using vinegar is also there. So the option D is the best answer here for the answer number 5. Right. 6. Right. What chemical reaction led to the discovery of the Bronze Age? What is the answer? Burning sulfur-rich rocks. Heating very high temperatures. Covering a fire with copper-rich soil. Mixing iron with carbon. And the last one, fermenting organic matter. What is that? Covering a fire with carbon-rich soil. Copper-rich soil, sorry. C, right? C. 6. 7th one, what compound is formed when ethanol undergoes oxidation? Tell me, what compound? Methanol, carbon dioxide, acetic acid, propanol, hydrogen gas. Acetic acid, what is that called? Acetic acid is called vinegar, right? Very good. Acetic acid is C is the answer. 8th one. Which of the following is not a subdiscipline of the modern chemistry? Organic chemistry, inorganic chemistry, astronomy, analytical chemistry, physical chemistry. Chemistry, only astronomy didn't have that. Right. So, what is that? C. Right. 9. 9 is, okay? Right. 9. What is the primary function of antiseptics? Enhancing the flavor of food. No. Preventing bacterial growth and living tissues. Yes. Strengthening metals? No. Increasing the shelf life of fuel? No. Enhancing plant growth? No. B. And the question number 10. What is the question number 10? Which of the following is not considered as a fossil fuel? Petrol is a fossil fuel. Diesel is a fossil fuel. LP gas is a fossil fuel. Natural gas is also a fossil fuel. Methanol is the not fossil fuel. Methanol, usually you get it from plants. Fermenting plants, you can plant-based material, you get ethanol and methanol. Right? So now you can say, okay, 10 marks, 10, 10, 10, 10, 10, 10, 10, 10, 10. Altogether 100. Now you can put your mark out of 100, don't show it to me. But then did you get 100 out of 100? Only 2 out of 100. 100 out of 100. Good. Others? You all got good marks? Right. This is the first tutorial that you have done, right? You have 100 or 100, keep it. And that means you have done your O level well. Right, okay. Right. So, no, it's okay. Don't worry. Right? There's another one more question, but I want you to, we will look at that. Okay. Right. Okay. So that's good. You guys are brilliant people. Near mine. So I think this is it. Are okay. So can you take your book out and we will write down very, very short, short description of the material that we have done today for the moment. Description of the material. Take your book out. So I'm sure you have a book to write certain things. Neither. Another. Right. Right. Let us write down these parts. Just to get an introduction. Just to get an introduction, we will write down these ones. Now, these ones that we are writing today, you will never be examined on that. But we need to have a proper background to understand chemistry. So that is why these things are there, right? So let us write down, right? Development of chemistry concept. Development of of chemistry as a subject. Right. Now, why do you want to study chemistry as a subject? Now, this first lesson here today, you are trying to get to know me, how I speak and how you can write, and we like to understand our strengths and weaknesses gradually. And next time we can do it little better, right? So the first one is like we try to understand the origin of the world. I told you it might be the God's creation or it might be a Big Bang there. But whatever it is, we are in that earth. And we have so many challenges like survival. So I'm going to write one sentence on that, right? Let us write down the evolution of human, evolution of human survival was through competition for food, competition for food and safety. Competition for food and safety. The MEMA may, you don't need it, but you have to understand why we are doing certain things rather than, syllabus, you need to kind of understand why we are doing something. So that is why. This is, you understand a kind of a gradual history, right? Survival, food and safety. So when we realized that, all these animals had a kind of a bigger age than mankind. So we wanted to create our own tools. And that is how stone technology began. So I'm going to write the second sentence based on that. So write it down. Second one, write down. Humans faced many disadvantages Second one. Humans faced many disadvantages compared to other animals. Compared to other animals. But their intelligence, to the same line, nah? But their intelligence intelligence allowed to make tools from the surrounding. Tools from the surrounding. So it's called obsidian, remember? Obsidian. Obsidian. Right. Right. Now what happens? What is the second thing, third thing that happened? Like, after this, they understood how to make fire. That making a pivotal role in surviving the mankind, giving that extra edge of survival. It gave you warmth. It scares away the predators. It changes material that you place there so that you can fire clay and make various types of storage containers. We will write one line based on that, right? Third one, discovering, third one, discovering fire, was important. Fire was important. Third, the mankind to survive. For mankind to survive. Are you writing? Mankind to survive. Right? But one thing, as far as the chemistry is concerned, there's one thing. What is that one thing? Whenever you place something in that inside fire, you see some kind of a transformation. Its appearance change. If you keep a piece of paper in fire, it burns, it appears differently. If you keep those things in fire, it appears differently. That is what happened when you place clay also. It gives different properties. We call that transformation. Transformation. It's very important. This word is very important for chemistry. So that is why I write it like that. Right? I'll tell you why it is important in a minute. Let's write down. They also observe that fire can trigger chemical transformation. Fire can trigger chemical transformation. Fire can trigger chemical transformation. You can transform materials into some other material. That is called chemical transformation. Fire can trigger chemical transformation. So this is what happens when you keep clay. It gives you a kind of a rigid material that doesn't shape, that doesn't change the shape. You can store water, you can store various types of materials. So I'm going to look at the fourth one based on that. Right. You can write down. This helped, this helped helped to make durable containers. Durable containers from clay. And at that time, it was a new thing. So we say revolutionize the storage of various types of food materials. So at that time, it was revolutionized. Right now, we don't look at a clay pot and say, ah, this is something that revolutionized the mankind. Yeah. It's like new Apple phone appearing in their life, something like that. Okay, so let us write down one line to this one. This revolutionized, this revolutionized food storage. Food storage. Okay. So now remember, can you remember that? Like what happens now when you start storing food, only you realize that it gets spoiled. So what did they do? They use various types of chemicals. We are not saying chemicals, but various types of chemicals are being used. What is the common chemical that they use? They use vinegar. Vinegar is a chemical. The chemistry part is CH3COOH. This is your vinegar. This is the chemical. But we call it vinegar because it was taken from natural various types of materials. Alcohol fermentation gave you vinegar. And you use vinegar to preserve this. So these are food, various types of preservatives, right? Next one, right? Food preservatives such as food preservatives such as vinegar. Vinegar. Now let us write a molecule here, right? Let us try to write let us try to become a little bit more advanced on this. Vinegar, what is vinegar? CH3COOH. Right? CH3COOH, acetic acid. Vinegar was used as a preservative. Vinegar was used as a preservative. Full jolly in everybody is like, in a kind of a jolly state of mind. There's a lot of food. You can keep it for a long time. You can keep it for an even longer time. So there's now more room to observe nature, make various types of arts. You can think about things that is happening, philosophical thoughts. Everything is good, right? Until one of those philosophical thoughts, they thought, let us fight against each other. That is where these new, early inorganic chemistry happened at that time. They were putting some rubble on that. So they start discovering various types of metals, metallurgy, metals. That is the next one. You can write down. Sixth one, early inorganic chemistry began. Okay, right. Early inorganic chemistry began. Early inorganic chemistry began. Chemistry began with accidental, with accidental reaction of copper-based minerals on fire. Copper-based minerals on fire. Right? Now I'm going to write that very early reaction that took place. Huh? Right? What is this copper-based material? I told you copper oxide. Okay? Cu, have you heard Cu? Copper. Copper oxide CuO. Copper and oxygen connected together. They're chemically bound together. In fire, you obviously have carbon. So there's this carbon. Right? And in fire, you have a massive heat. So what will happen is this carbon will steal the oxygen from copper oxide. So steal the oxygen and it forms carbon dioxide. And then it gives you copper out. Now that is your first reaction. Let's see whether you can balance it. When you balance it, you look at the left-hand side, you look at the right-hand side. It's called the observation method. Right? Observe and try to put some numbers. So oxygen is 2 here. So you put 2 here. This is the only place you have oxygen. You put 2 here. Now don't worry about it. I will learn this as a proper technique and we will practice it better. Oxygen is balanced. Now you can see copper is not balanced. 2 copper here, right? 2 copper, and you need to have 2 copper as well. Balance check whether everything is balanced now. So 2 copper here, 2 copper. 2 oxygens here, 2 oxygens. 1 carbon here, 1 carbon here. Carbon dioxide is a gas, it evolves out. Copper now is a metal. This is this new metal. This new metal, there's nowhere else to go. It is going to stay there. So it gives you copper, like that. And you take that copper. Here, it gives you very special properties, very new properties. They're more ductile. They can be sharpened very easily. So completely different physical property. Copper oxide, if you hammer it, it just breaks. And this has completely new properties. And this is the first time they have ever encountered something like that. And they use that. Right? You can write down the reaction. Write down the reaction. Right. Very good. Right, okay. So then the next thing happened was this. Right? After this, they were very curious. Now, everybody is curious. Like, usually now you will soon see when I describe some of those experiments. When something happens in one place, everybody is trying to see whether similar things are happening in the other places as well. It's like a fashion. It's like a fashion, right? So, like, if somebody is wearing something today, within a week, it goes everywhere. Everybody is wearing the same thing. It's like that. Just like that. Even for the experiments, it's like that. They start to do some experiment on one place, and everybody start doing the same experiment in the other places and see whether there are new observations. Right? So people try to do this. If you do the same thing using iron oxide, FeO, right? Iron oxide, you have done this for the O-levels, right? Iron extraction. What do you use? Carbon or carbon monoxide? Carbon monoxide. Carbon or carbon monoxide? Monoxide. You use carbon monoxide. When you use carbon monoxide, this carbon monoxide take this oxygen and you will get iron and you get carbon dioxide. Right? Did you understand that? The similar kind of thing. Similar kind of thing, whether you use carbon or carbon monoxide, it can steal oxygen. You remember you did blast furnace? Was it in the exam also this time? Ah, no, luckily no. Okay, right. Did you understand that? So, like, I don't know, I didn't see, right? But that is how you extract iron, and you get the Iron Age, Bronze Age, then Iron Age. All these different types of metals you can extract, right? You can write down in a similar process. Write down in a similar process. Hurry. In a similar process, in a similar process, similar process, similar process, various other metals have been extracted as well. Various other metals, other metals have been extracted as well. Different types of metals, right? So I want to put this into only 10 terms. Now we are at sixth, seventh. Seventh. Six, how many points did I give you? 7 points. Another 3 points. I don't want to go beyond 10 points, right? Okay. So what I'm going to say is this. Are you ready to listen? Right. So I'm going to say up to this point, you can see most of these discoveries are accidental discoveries. I talked about phosphorus. There are many other examples. They never went seeing, I'm going to find a proton, I am going to find a phosphorus killer DNA. They never did that. They were trying to find something else and they found something else. But they were very open-minded to understand what the nature told them. All the scientists are like that, right? So this chemical curiosity, 8-pointer, this chemical curiosity with various peoples, different people in different countries, they had that curiosity in mind, and that helped us to discover different types of elements. There are 118 pure elements that is discovered to date. Most of these elements in the periodic table, if you look at that elements in the periodic table, most of the elements in the periodic table that is located in the upper part of this, they are naturally made elements, these elements. These ones that are in the very lower part, they are artificially made elements. They're man-made elements, some of these elements. What they do is they take two particles, allow them to hit with each other and become a unity and make a new type of elements. They're called radioactive elements as well. So all these elements that is in that periodic table, they are discovered because of the curiosity of the mankind. And that is why when I give you this periodic table, I told you this is like an anthropological marvel, man-made marvel. Minissunge mara bedak. That's what this one. Right? But we don't appreciate it. But this is one of the marvels in the mankind, the periodic table. So I'm going to write that 8th sentence dedicating to that. Right? Yeah. The curiosity of mankind, curiosity of mankind, curiosity of mankind help to discover, help to discover various types of other elements, various types of other elements, other elements. Within brackets 118, 118 elements. various types of other elements, 118 elements, that is given in the periodic table. That is given in the periodic table. Clear? Right. That is given in the periodic table. Now I have only 2 points here. Right. Let us look at the 2 points. So that is how all this history here, that is how you finally bring these elements. When you try to understand their concepts, how these elements react, how these elements bind to each other, what are their new properties. And that study is what is called chemistry. So chemistry is nothing new to you. It's like, what is this? We are trying to understand nature, right? We are trying to understand nature. I don't know whether it's the God's creation, right? Nature, maybe people think it's a God's creation. We don't know. But we are trying to understand that nature in a scientific point of view. In that strategy, chemistry means this. We try to understand how atoms build up new compounds. We say structure. Structure. How these structures are formed, we say composition. Structure and composition, how these structures are formed. And how these structures, how these compositions can transform. That is why I wrote the word transform here and I told you it's very important. Transform. Right? The structure, composition, how they transform their properties. Right? And then finally, we want to understand the energy related to that. Energy. It's a very scientific jargon. Like when you write it, sometimes you might not understand, but I try to put this into simpler terms. What do you mean by chemistry? If you take a compound, it turns into something else. Take one example. Let us say you have methane. Methane is a natural gas. It is the composition. Methane is called natural gas. Methane, CH4. If you want, now you have the structure, you have carbon and hydrogen. Composition is made out of carbon, made out of hydrogen. Structure, 1 carbon, 4 hydrogens. Transformation, let us say you burn it in the presence of oxygen. Can you tell me what are the products that you get? Methane burned with oxygen. What is that? What are the products that you get? When you burn something, what are the products you get? Carbon dioxide, CO2. What else? H2O. Then you have a transformation. You have one material turning into another material, carbon dioxide and water. Right? So structure, composition, transformation, their properties. Carbon, methane is a gas, oxygen is a gas, carbon dioxide is a gas, but water is a liquid. Their properties. And how this transformation takes place. And you know, whenever you burn something, it gives out energy. And it gives you, other than this material, it gives you energy as well. So chemistry is all about understanding that concept. One material turn into another, transformation, and how does the transformation take place, and what is the energy related to that? When you try to understand that, we call that, it is the study of the nature in terms of chemistry. Chemistry means that, nothing else. Then, did you understand that it's a science of transformation? One matter turns into another matter, turns into another matter. Things change. And what is the science behind that? That is called chemistry, right? Okay, so let us write down new paragraph. That's the important one. You can use a different color and write down. I sometimes ask you to write different colors. Why? Just to highlight that part, right? Let us write down here. Modern chemistry is a discipline that study modern chemistry is a discipline that study. Modern chemistry is a discipline that study. Discipline that study. What do you study in chemistry? What? The structure. What do you mean by structure? Now, don't write just the word. I want you to understand it. What do you mean by structure? How it is bound to each other. That is what you mean by structure. Is the study of structure. Is the modern chemistry is a discipline that studies the structure. What else? Composition. What is it made out of? What is it made out of? Composition means what is it made out of? Structure, composition. Then I will write properties. Properties. And transformation of matter. Transformation of matter. Structure and properties and transformation of matter. And its related energy. Its related energy. Its related energy. Did you understand that part? Even if you forget everything else I told you, I want you to understand that part. The summary of everything is that whenever you study chemistry, it's like a transformation. Something turns into another thing. Look at, like, imagine all your chemistry work that you have done. All of them, whenever you write something, you had a arrow like that. You had something on this side, and then you had something on the other side. So what does this arrow tells you? It's a transformation. You have been studying transformations. You might have written so many reactions. All of these reactions tells you one material turned into another material, right? It won't destroy, it won't get created. Some material turning into another material. So that's what's been doing. When you say you are measuring the energy, you are looking at the energy related to that, right? You're measuring various types of things, right? But what you study is a transformation. Something turn into another thing. So if when you go home today, your parents might ask, okay, we learn chemistry. What is chemistry? Chemistry is the science of transformation. They might not understand it, but you understood it. What is the science of transformation? Something turn into another thing, the science behind that. We are looking at the structure, how atoms are connected, composition, what atoms are connected, transformation, how these atoms turns into these atoms, and properties. What are the properties that are there? And the energy related to that. Energy is very important. Without energy, you can't do. Sometimes you might have to supply energy. Sometimes it gives out energy. So science behind that is what is called chemistry. Did you write that sentence right? Did you write that sentence properly? It's a study behind the structure, composition, properties, and transformation of material. One material turning into another material. You can write down to the same thing, the more only, very important ones. This is further classified into, this is further classified into, this is further classified into several branches of chemistry. This is further classified into several branches of chemistry. Several branches of chemistry. What are these several branches? First one is called general chemistry. General chemistry. Right. What is the second one? organic chemistry, right? Next one is inorganic chemistry. Inorganic chemistry. Right? Note එක හොඳට ලියන්න ඕනේ. It's very important to have a proper note at the end. Inorganic chemistry. Then the third one is what? Organic chemistry. Organic chemistry. Next one. What is this one? Next one. Huh? Physical chemistry. You are looking at the mathematics of this. Physical means that. How does, so it's important to know mathematics also, right? Physical chemistry. Physical chemistry, right? Then you have, what else? You have something called analytical chemistry and biochemistry. We don't have analytical chemistry and biochemistry in A levels. When you do higher studies, you might end up getting them. So I'm not going to write these two, analytical chemistry and biochemistry. But we are writing only the ones that we have in our A levels. So next one is, what is the next one? Industrial chemistry, right? So industrial chemistry. And the last one is what? What is the last one? What is the last one? Environmental chemistry. Very good. Environmental chemistry. Niyama, yeah. Very good. Environmental chemistry. Right. Okay. Right. Is it clear now? How many points did we use? 9 points or 10 points? How many points? Now 10. 9. 10 now, okay, 10 points are okay, right? So this is where we begin. Look at it, right? Now in A levels, what we have is, we normally start studying with the general chemistry. Inside this general chemistry, there are 4 topics, right, that we need to look at. First one in general chemistry is called atomic structure, the structure of atom. Second one is called bonding, how atoms bind to each other to form new molecules, bonding. Third one is chemical calculations, right? Different types of calculations that you need to do, like the moles, concentration, there is simple calculation. Fourth one is called, we are looking at the gaseous state of matter, gases. And then we try to look at the energy. I told you energy is also important. That's called thermochemistry. They are the ones that is under general chemistry. So you can write down. In general chemistry, there are 5 main topics. In general chemistry, there are 5 main topics. And I can't remember whether it is 5 or 6 or balum count karla. I'm very bad at counting, right? How many topics? 5 topics, right? First one is called atomic structure. You can write down atomic structure. First one is atomic structure. What is the second one? Second one is called bonding, chemical bonding. Chemical bonding. Right, chemical bonding, right? Okay. The third one, what is the third one? Chemical calculations. You remember these moles that you have calculated, concentration calculations, those kinds of very simple topics there. Chemical calculations. Chemical calculations. Right. That is the third one. Are you clear? Right. Fourth one is gaseous state of matter. Gaseous state of matter. Right. And the last topic here is energetics of a reaction. Right. Energetics of a reaction. No, right? Okay. So out of that, we are going to start with this topic today, right? Hurry. Write down the main topic. Atomic structure is the first topic that is there. Now, අපි ඉවර කරන්න කියනද 3:45 නේද? Today 3:45. 3:45. We started at 1:45, so today we will finish at 3:45. Starting from next week, you will have a little bit of a පොඩ්ඩක් ටිකක් වැඩි කරලා කරමු 1:30 to 4:30. No 30 minutes break නෑ. 10 minutes විතර break එකකුත් දෙන්න. Right? හරි. Okay. 3:45. Right? Okay. So let us start with the topic atomic structure. Next week I will do some experiments based on that as well. Atomic structure. Write down the topic atomic structure. Let me put the slide to you. Make it I'm right. Just a minute. Hurry. Let us straight away start writing the topic atomic structure. Right. So atomic structure, this is how it works. If you look at the surrounding, now I told you the men were very curious. They were looking around the surrounding and they understood there are two types of things. One is called matter and the other one is called energy. What is matter? What is matter? What do you mean by matter? Matter, I didn't say what is the matter. What is matter? Anything that can occupy space, very good, and has a mass towards it, we call it matter. Divided into three categories. What are the three categories? The solid, liquid, and the gaseous state. Now, anything that doesn't suit under that category is called energy, and it doesn't have a mass or it doesn't occupy space. Now, something that you already know. Let us start from there, right? Let us write down. Everything in the universe can be divided into two categories. Everything in the universe can be divided into two categories. Everything in the universe can be divided into two categories. So first one matter, second one energy. Matter and energy. So you have had very good teachers in O levels. That's good. Matter. First one, second one is energy. Right. Let us write what is matter. Let's write down matter. Matter. What is matter? Right. You can write your definition. Now, what is matter? Anything that occupies space, anything that occupy space in the universe. And having a mass is called matter. Right, is called matter. Right, very simply, right, let us write down divided into three states. Divided into three states. What are the three states? Can you understand? What are the three states? Solid. Right. Solid, liquid, and gas. Solid, liquid, gas. Can you tell me examples for the solid state? Can you give me three examples? Solid state. Something solid. Ice. Muna ice. The fridge ice. Right? Not the other dangerous one. Ice. What is? What is? Something solid. Something solid. Something solid. Bottle, yes, the bottle. Well, let us become more chemistry oriented. So let us say salt, salt, sodium chloride. What will happen? What else? Let us say diamond. What is diamond? What do we have in diamond? Carbon. Carbon in a certain crystalline form. These are solids, right? Chemical aspect. Now tell me liquids. Water. H2O. Water in the liquid form. What else? Can you tell me some other liquid? Don't tell Fanta, Coca-Cola, you can know, right, but you are now advanced. So what are the other liquids? HCl is not a liquid. What else? Water, yes, what else? What are the other liquids that you know? Alcohol, yes, alcohol. Yes, alcohol. C2H5OH, alcohol, yes, very good. I don't know. I'm just not laughing at you, I'm laughing with you. What else? What else? There's something else. Vinegar. Right, vinegar is also a liquid, right? Okay. Water. Now have you heard chloroform? Something called chloroform? Right. So let us write down that. Chloroform. CHCl3. Right. Chloroform is also a liquid that is there. CHCl3, water, ethanol, and chloroform. These are liquids. Clear? Did you understand? Gaseous gases. Can you tell me what are the gases? You can name many gases. What are those? Most important gas in the universe. Oxygen, yes. What else? Nitrogen, yes. What else? Carbon dioxide. All of them are gases. Clear? Right. Okay? Yeah. Now, anything that doesn't suit under that category, they are called energy. Right? You can write down. This is matter, we said, right? Now we say energy. Energy. Anything that does not occupy space. Anything that does not occupy space and doesn't have a mass and does not have a mass are known as energy. Example, can you tell me what are the examples? Example, three examples. Energy forms. Heat. What else? Energy, something else. Light, yes. Heat, light. And then what else? Huh? Nuclear energy. Nuclear energy is also energy. Yeah. Sound. Yes, sound as well. Right. So all these are energies. This is matter. Now, at the very beginning, people understood that there's this solid state, there's this liquid state, there's this gaseous state. They want to understand how these different states are formed, how this matter is actually formed. Those investigations led to the discovery of the structure of atom. I think that is a story for the next time. How do you really understand how do you understand the structure of atom? Next week we will do some experiments at the same time do this, right? Right, okay. Hurry. Now you have 1 more minute to go, huh? One more minute there. Right. So next week we will start the class at 1:30. Harida, 1:30 p.m. So 1:30 p.m. and we will go till 4. Not 4:30, 4 p.m. Then Islam, I don't know whether it is tiring for you, right? So 1:30 to 4 next week. And so I will start with the next topic. Now tell me, what are the things that we learned today? What are the things that we learned today? If somebody asks you, what did you learn today, Kelman? What did you learn today? Chemistry is about, again, the chemistry is about transformation. One material turned into another material. Composition. Then structure, properties, transformation, and the related energy. Hari? You don't have homework. Not now homework, right? So write the material. Next day when we come back, we will do some pretty practical work and we'll learn about how to build up the structure of that. Right? Okay. Thank you very much for being here today. And I hope you understood what I try to teach you. Right? Okay. Thank you. Right. So see you next Friday. Right? Right. Thank you.